Good, so you notice that this is absolutely correct. Now I was just discussing there, why is this not just x squared plus 16? Now you said there's a rule for it, and I agree, like there is a rule for it, and I'm a really big fan of rules, but I want to understand why it works as well, because if you understand why it works, then you're just allowed to use the rule, right? You're not just allowed to use the rule on your own. So why is this not just x squared plus 16? It's a common mistake which people make. They see an x, they see a 4, they see the square, and they think, I just square that and square that. Why is it not that? Why is it that?
Because when we multiply the x times x, then the x times 4.
Okay, so what you're thinking of is, okay, x plus 4 all squared literally means...
X plus 4 times x plus 4.
Good. So times it by itself. But my question still stands, why is it not just x times x and 4 times 4? Why? So why have we got to also do the 4 times the x and the x times the 4 as well? Why have we got to add those two red lines in? It's the way it's supposed to be. You're right, we are supposed to do it like this, but you still haven't answered my question. Like, come on, we're mathematicians. Like, you must be able to say why.
There are, between brackets, we need to multiply each number by the two numbers in the other bracket.
Why? But you see, this is getting into the idea of proof. Now, the thing which distinguishes maths from every other subject is this idea of proof. Once you prove something in mathematics, you've proved it for good. Nobody can dispute it, right? Yeah, I know. But, yeah, can you tell me why this makes sense? Why do we have to do it this way? Why can it not be just x times x and 4 times 4? Think about this.
So we have to like prove or something?
Well, I want you to give me a convincing argument as to why we have to do it like this. Okay, so we're squaring something. Now, you remember when we did our surds and indices, I said we don't say this as x plus 4 to the power of 2, like we do with other powers. If this was like a 10, we'd say x plus 4 to the power of 10. If this was a 15, we'd say x plus 4 to the power of 15. Why do we say squared and not to the power of 2? Can you remember? Why do we say squared?
Why wouldn't you say 2 times 2 is 4? Why wouldn't we say 4?
Well, okay, then why couldn't you say 2 to the power of 2? Why do we not say 2 to the power of 2? Why do we say squared instead? Good, so it's something to do with a square, right? Something to do with a square. So actually, let me draw out a square, and let's see how we can relate this to this. Okay. So you remember when I was like, okay, this we would say 5 squared. By the way, what is 5 squared? 25, good. Now, what property of a square am I looking at if I apply this operation? So if I square something, I'm looking at the area. Spot on. Okay? And in this case, what does the 5 correspond to? What property of the square does the 5 correspond to? The side. Good. So in which case, if I come back to here, x plus 4 all squared, okay, that should be my side length. My x plus 4 should be my side length. Does that make sense? So here's my square, all right? Here's a side length. How can I write x plus 4? So how can I think of x plus 4 in terms of this square? I can think of it in terms of from there to some arbitrary distance is going to be x, and from there to there is going to be a length of 4. Are you happy with that? Yeah? So I've basically broken this side up into 2 parts, x and then another 4, x plus 4. Make sense? And obviously, all the side lengths are going to be the same, including this one. So this is going to be x, and this is going to be 4 down here. Does that make sense? Where am I going to go next? Because remember, I need to talk about area if I'm squaring something. So what am I going to do to this square next?
Perimeter?
Well, okay, I've got x plus 4, I've got x plus 4. I've broken the 2 side lengths up into x and to 4. What would you do with this square next if you're going to move towards area? Think about the diagram which I've drawn.
2x plus 8.
Well, would you be happy? First of all, I'd continue this line down here. So now I've got a kind of area that corresponds to this 4. And likewise, I could also continue this area across here, because now I've got another area that corresponds to 4. Bless you, Megan. So, can you see now that I have 4 parts? I have 4 parts to my square. What's the area of my first part?
X squared.
X squared. You happy? It's just x and x, so that square has to be x squared. Okay. What's the area of this small little bit down here?
4 squared? No.
It is 4 squared because you're happy that height is 4. And that length is also 4. So it's 4 squared. You happy with that? Yeah? But can you see now that it's not just x squared plus 16 like I said, yeah? Because I've still got 2 areas that I need to take account of. Does that make sense? Yeah? So what's the area of this bit? 4x. And what's the area of this bit? Another 4x. Hence why I have to have that 8x in the middle, because together they will make my 8x. Does that make sense to everyone? Yeah? So this is the idea of proof. It's like, don't just tell me it's like that because you've been taught it. Actually think, why can it be like that and not anything else? Does that make sense? Good, fantastic. Yeah, so like I say, let me get rid of this section. This is a really useful form which we can leave our quadratic in, yeah? Because we can clearly see, right, this is just a translation of x squared to the left by 4. And the same with this one. There's a bit more going on, but we can still see how we get this graph visually on a graph just by moving this about, yeah? However, like I say, we're nearly always given it in this form here, okay, in expanded form. And likewise this, we're nearly always given in this form here. And I said there is a way of going back from here to here. We will look at it probably next Friday, so a week's time, okay? But in the meantime, I'm interested in drawing this graph. Like I introduced quadratics to you by actually drawing them. I want you to actually think about how we can draw these graphs. So I'm not actually going to give you these graphs. I'm going to give you slightly easier ones.